Have you ever been asked to create a new database and felt completely stuck on where to start? You know you need tables, relationships, and primary keys. But the moment you open your diagramming tool, you're staring at a blank screen, wondering what goes where. Or maybe you've inherited a database from another developer and it's a complete mess. Duplicate columns, inconsistent naming, and mysterious relationships. Then you find that every new change seems to break something else. If that sounds familiar, you're not alone. Most developers were never actually taught how to design a database. They learned SQL, maybe some normalization, but not how to go from requirements to a clear, structured design that just works. Hi, I'm Ben Brum from Database Star. I've spent over 20 years working with databases and many of those years teaching thousands of developers and data analysts how to do the same on my YouTube channel. And in this video, I'm going to share with you my 5-step blueprint for designing any database, whether it's for a web app, an internal business system, or your own side project. It's the same framework I use when I start every new design, and once you understand it, you'll be able to take almost any set of messy requirements and turn it into a clean, professional database schema. By the end of this video, you'll know the biggest mistake developers make when starting a new database project. The 5 simple steps to go from an idea to a finished design. And how to use this blueprint to save hours of trial and error on your next project. And if you stay until the end, I'll also show you where you can get the full set of materials and examples I use inside my course, Effective Database Design, so you can apply this framework in the right way. So let's get started, and first let's talk about why most developers struggle with database design in the first place, and why it's actually not your fault. Before we get into the 5-step blueprint, I want to clear up something really important, and it's something most developers never hear. If you struggle with database design, it's not your fault. Most people are thrown into database projects without any real guidance. They're expected to magically know what tables to create, what relationships to use, how to structure data, what should be its own table and what shouldn't. But there's a problem with that. Most developers are taught SQL, but they're never taught database design. You learn select, join, and group by, and maybe a bit of normalization, and then you're sent into the real world to create databases without a process, without a structure, and without a roadmap. I wasn't taught how to do it at university when I got my degree. We focused on the normalization steps, understanding what each of the 3 normal forms was and what they meant. Terms like transitive dependency were drilled into us. Then we get into the real world and we've got existing systems to work on or new projects to start. Of course, it feels overwhelming. Of course, it feels like guesswork. Of course, it leads to messy, inconsistent databases that are hard to maintain. This isn't from a lack of skill. It's because you weren't taught how to do it in the right way or how to do it at all. So the first shift I want you to make today is this. It's possible to design a good database without having years of experience or being a DBA. Now, to really understand this, I want to show you the first big secret behind great database design. This one completely changed how I approach every new project. The first secret is this. Database design is a process, not a guess. Most developers treat database design like a puzzle. They open up their diagramming tool, they drag around some boxes, and they hope it all makes sense by the end. But professionals don't work like that. Professionals follow a blueprint, a repeatable process that they can use no matter what system they're building, whether it's a booking system, an online store, a CRM, or anything else. And that's the difference. Every reliable, scalable database you've ever used wasn't the result of someone guessing their way forward. It was the result of a clear design process. This is true for both smaller applications you may have used as well as larger applications. It's the system I use when I design any of my databases for my YouTube videos as well. Let me tell you a quick story. In one of the places I worked, there was an application we were enhancing. It was written about 10 to 15 years ago and slowly added to over time. Now, 10 to 15 years can be a long time in software, but it's not surprising that the system was this old. The software changed teams and a lot of work went into it before I started there. What we found was that there were many enhancements that were not done in the best way. There may have been deadlines to meet or other pressures that meant the team couldn't come back to improve the code and the database. We ended up with a system and database that worked, but it was hard to change. There were no foreign keys in the tables, so we couldn't see which tables related to which other tables. There were over 1,000 tables, many of which were no longer used, so we didn't know what was safe to delete and what was still relevant. Things were slowing down, and the team decided they needed to spend some time to improve it. At the time that I left, the team had started making progress on the improvements. They had a vision of where they wanted to go and where the big improvements could be achieved in the system. And most of the mess was in the database itself, not the application code. Here's the point. Good database design isn't about experience with databases, it's about following a process. If you follow the right steps in the right order, even if you've never designed a database before, you can create something that is clean, scalable, and easy to work with for years to come. But if you skip steps or do them in the wrong order, the design starts breaking down. It's like building a house. You don't start with the windows, you start with the blueprint, then the frame, then the structure, then the details. Database design is very similar. And that's why this 5-step blueprint works. It gives you a path to follow, a way to take all the chaos and uncertainty of working with software and requirements and turn it into something precise and predictable. Because once you treat design as a process, you're no longer guessing at what you need to do. So now that you know that database design is a process and not an art, not a talent and definitely not guesswork, let's walk through the exact 5 steps you can follow to design any database from scratch. This is the same blueprint I use in every project, and once you learn it, you'll never look at database design the same way again. Let's get started with step 1. Step 1 is probably the most important step in the entire process. Before you draw a single table, you need to understand exactly what the system needs to do. Most developers skip this step. They jump straight into creating tables because it feels productive. However, if your requirements aren't clear, then your design won't be clear either. So the first thing you want to do is gather all of the information you can about how the system is supposed to work. This can come from a client, a product manager or product owner, a document, other colleagues at work, or even your own notes if it's a personal project. The goal here is simple. You want to understand the real purpose of the system and what data it needs to store. I like to start by asking the question, what does this system actually need to do? If I'm designing a system for a doctor's clinic, I want to understand the entire flow. Patients book appointments. Doctors have schedules. Appointments may have notes, prescriptions, and billing. All of those actions become clues about the data we need to store. If it's an e-commerce database, I want to know how products are listed, how orders are placed, how payments work, and what information needs to be tracked for customers. Or if it's an enhancement to a banking app to allow certain customers to create new accounts, I want to know what steps they take, what information they might need to provide, and what checks may need to be done behind the scenes. You don't need to go deep into the technical details here. You're not trying to design the system, you're just trying to understand it. And one of the best ways to do that is to walk through real scenarios. Imagine a user going through the system from start to finish. What actions do they take? What information do they enter? What information does the system need to remember? Each scenario reveals more requirements, and every requirement becomes a building block of your database. As you gather these requirements, write them down as simple sentences. You don't need to worry about tables just yet. Just capture the behaviors. A patient books an appointment. A customer places an order. A user uploads a file. A customer requests a new account. These sentences become the foundation for your design. When the requirements are unclear, ask questions. Even simple questions can reveal important details. Does a customer need multiple shipping addresses? Can a doctor have more than one specialization? Can an order contain multiple products? Can an appointment be cancelled? Does the system store the history of changes? These questions matter because every answer impacts your tables, your relationships, and the overall structure of your database. If you've ever tried to fix a database halfway through a project, you know how painful it can be. It's not difficult, but ideally, you want to know this information as early as you can. Step 1 helps with that. By the end of this step, you should have a list of clear, simple statements that describe what the system needs to do and what data it needs to keep. You don't need tables or SQL or even a diagram yet. You just need clarity, because when the requirements are clear, the database design becomes obvious. And when the design is obvious, the rest of the process becomes much easier. This is how professionals start every project, and it's why their designs hold up over time. Now that we have clear requirements, we can move on to step 2, where we turn those requirements into the first version of our database structure. Now that we have clear requirements, we can start designing the database. And the first thing we do is identify the entities and the relationships between them. This is where the database design begins to take form. An entity is simply a thing the system needs to store information about. If you can point it to the real world or describe it as a noun in your requirements, it's probably an entity. In a doctor's clinic, the entities are pretty clear. We have patients, we have doctors, we have appointments. We might also have prescriptions, billing records, and notes. In an e-commerce system, we have customers, products, orders, and payments. These are all entities because the system needs to store information about them. Once you've identified the entities, the next step is to understand the relationships between them. This is where many designs go wrong. Good relationships make your database clear and flexible. Bad relationships make it confusing and fragile. So how do we find the right relationships? We go back to our requirements. Every action in the system is usually a relationship between two entities. For example, a patient books an appointment. That means one patient is linked to many appointments. That's a one-to-many relationship. Relationships tell us how our tables will connect. They give our design structure and meaning. As you're identifying entities and relationships, don't worry about fields or keys yet. We'll handle those in the next step. Right now, your goal is to get a clear picture of the big pieces of your system and how they are linked. I like to draw simple boxes for each entity and connect them with lines. No attributes, no primary or foreign keys, no database engine details. It's just boxes and lines. This gives you a high-level view of the system. And what you'll notice is that it starts making sense. The messy requirements you wrote down in step 1 now begin to look like a real database. You'll also start spotting gaps in your requirements. If an appointment links to a patient and a doctor, what happens if the appointment gets cancelled? Do we keep a history of changes? Do we need a status? These questions naturally come up as you map relationships. And that's good. It means the design is becoming clearer. By the end of step 2, you should have a simple diagram showing your key entities and how they relate to each other. You'll probably notice that it won't be perfect. It's not supposed to be. This step is about shaping the structure, not getting it perfect. In step 3, we take this rough structure and make it more precise by adding attributes, primary keys, and foreign keys. Now that we've identified our entities and relationships, the next step is to give each entity its structure. This is where we add attributes and keys. This doesn't need to be complicated. Attributes are simply the pieces of information we want to store about each entity. If the entity is a patient, attributes might include their name, date of birth, or contact details. If it's an order, we might store the order date or the total amount. The goal in this step is not to think of every possible field you could ever need. It's to capture the essential pieces of information that support your requirements, which we found in the earlier step. This is where a lot of developers get stuck. They either add too many fields or not enough, or they focus on the technical details too early. It's hard to find the balance. But at this stage, you just want to define what matters for your system to work. Once you've added the attributes, we introduce keys. This is what gives your database structure and reliability. A primary key uniquely identifies each record. It's what lets your system track individual customers, individual orders, or individual appointments. Without a clear primary key, your system becomes unreliable very quickly. Then we have foreign keys. These are the links between your entities. They tell the database how your tables relate to each other, and they keep your data consistent. Now, in this video, I won't go deep into the different key strategies or how to handle more complex scenarios. That's something I walk through step by step inside effective database design, because there are a lot of decisions that depend on your system, your vendor, and your requirements. But here's the belief shift I want you to make right now. Attributes and keys are about adding clarity to your design. When you add the right attributes, you make your data and your tables more useful. When you add the primary keys, you make your data more reliable. This step is where your design starts taking shape. You go from a set of boxes and lines to something that looks like a database, but is still flexible and it's still easy to change. You don't need to know every detail at this point. You don't need to finalize your column names, and you definitely don't need to write any SQL yet. You just want a simple, clear structure that reflects the requirements you gathered earlier. And once you have your entities, relationships, attributes, and keys laid out, you're ready for one of the most important parts of this entire blueprint, which is reviewing and improving the design. Because most of the magic happens in this refinement process, and that's exactly what we'll cover in Step 4. Step 4 is where your design really starts to tighten up. This is the stage where you review the structure you've created and make sure it actually supports the way the system needs to work. And the key idea here is this: nobody designs the perfect schema on the first attempt. What professionals do differently is that they validate their design early so they can fix issues before the system is built. So what does validation look like? First, you check that your relationships make sense. If a customer places many orders, does your design show a one-to-many relationship? If a product can appear in many orders, does your diagram reflect that? If an appointment must belong to a patient, is that relationship clear in your design? This is where you look for any relationship that feels unclear, inconsistent, or too complicated. The reason to do this is that unclear relationships are usually a sign that the requirements weren't fully understood, or that an entity is missing, or that something needs to be simplified. The second part of validation involves normalization, but we keep this simple. Normalization is really about one thing: making sure that your data is stored in the right place, without duplication, and in a way that the system can rely on. You don't need to memorize every normal form. You don't need to run your design through a formal checklist. What you want at this stage is the ability to ask simple questions that reveal any design issues. Are you storing the same information in multiple places? Does every table have a clear purpose? Are there any attributes that belong somewhere else? Does the design support the scenarios and requirements we captured back in Step 1? These questions help you spot problems early, which are problems that can become expensive and difficult to fix later. Now, inside effective database design, I walk through this step in much more detail with examples and patterns you can follow. But here, all I want you to understand is the concept. The aim of this validation is to improve the stability of the database. By the end of this step, your schema still won't be perfect, but it will be logical and consistent with the requirements you gathered earlier. You'll start to see the design take shape in a way that feels intentional. Then, once your design is validated, you're ready for the final step, the step that actually turns your design into something ready for real-world use. Let's move on to Step 5. Step 5 is one of the most overlooked parts of database design, but it's also one of the most valuable. This is the step where you take your design and review it with other people. This can include your team members, your product owner, your business stakeholders, and anyone who truly understands how the system needs to work. This is because you can create a technically perfect database and still have it fail if it doesn't match how the business actually works. When you've spent hours designing a schema, you see everything from a technical point of view. But the users and stakeholders see it from a workflow point of view. This is where the biggest disconnects or misunderstandings can happen. So in this step, you sit down with the people who understand the real-world process and walk them through your design at a high level. You're not showing them field names or data types. They probably don't care and don't understand. You're simply explaining the flow of data. We have a customer, and a customer can have many orders. This is how the system tracks payments. We store this information about appointments. This table keeps the history as we want to capture those changes. When you present a design this way, people who aren't technical can still give incredibly valuable feedback. They'll tell you when you've misunderstood a rule. They'll explain situations that only happen once a year but need to be considered either to include them in your design or to change their process. This feedback is very handy because no matter how good your process is, there are always business rules hiding beneath the surface that don't show up in the initial requirements. This step brings them to light before you start building, which saves an enormous amount of time later on. Once you've gathered that feedback, the next part is to improve the design. This doesn't mean starting from scratch. It simply means adjusting the structure based on what you've learned. For example, maybe a relationship needs to be changed. Maybe an entity needs a new attribute. Maybe a workflow needs its own dedicated table. Maybe a concept you thought was simple actually has multiple variations. This is all normal. In fact, the best database designs always evolve after the first review. Inside effective database design, this is something I teach and encourage. But for now, I want you to walk away with this one idea. Database design is not something you do alone. It becomes stronger when you involve the people who understand the business. Your responsibility as the designer is to take all that insight, all that domain knowledge, and turn it into a structure that's logical, scalable, and easy to maintain. That's what this step is all about. And when you combine this collaborative review with the first 4 steps of the blueprint, you get a database design that makes sense technically and works perfectly for real users. Now at this point, you might be thinking, Ben, this all sounds great, but I'm not a DBA. Can I really design databases at this level? And that leads us straight into secret number 2, which might completely change how you see yourself as a developer. Now that you've seen the 5-step blueprint, there's a belief that often comes up for people at this stage, and it's something I hear all the time. They say, Ben, this all makes sense, but I'm not a DBA, I'm not an architect, I don't have years of experience, can I really do this? And the answer is absolutely yes. Because database design is not a job title, it's a set of skills. I've worked with developers, analysts, testers, and even students who had never designed a database before. And once they learned the process, they created designs that were cleaner and more reliable than people with far more experience. One team I was working with had a pretty complex setup for their project. They were creating a new version of their application and database from scratch, but based on the existing business rules. They were having trouble with the new design and weren't sure how to capture it all in the right way to avoid the problems with the current design. They had great development skills. They knew their way around several programming languages and developed and supported this great system. But they were struggling with the data modeling. I used this 5-step process with the team. I asked them about the requirements and we captured those. Then we worked through the rest of the process, capturing entities and attributes, attributes and relationships. We validated the design based on what we knew. The rest of the team, the developers, took the lead on these steps from my initiation. Then we discussed it with others who knew more about the domain and made some changes. In the end, we had a design that worked well for our needs, was better than the old design, and I think we got there quicker than what we would have done using the existing approach. And the developers followed the process themselves. This is why I often say you don't need to be a DBA to design a great database. You just need a process. Once you have a process, database design stops being mysterious. It stops being something only experts can do. It becomes something you can approach with confidence. The blueprint gives you clarity, structure, and it gives you the ability to design databases that other developers actually enjoy working with. Now, does the process go deeper than what we can cover in a single video? Of course it does. There are decisions, patterns, and techniques that depend on your system, your data, your vendor, and your goals. And that's exactly why I created Effective Database Design, to give you the complete walkthrough with real examples and templates so you can apply this process exactly the right way in your projects. But the key message of this secret is simple. Your background doesn't limit you, your process does. And now you have the process. But even with a solid process, many people still hesitate because they think something external is holding them back. They say things like, I don't have the right tools. I don't have expensive diagramming software. My company won't give me extra time for design. Or it's too hard to do this properly without a huge budget. And that brings us to secret number 3. So at this point, you've seen the blueprint, you understand the process, and you know you don't have to be a DBA to design a good database. But there's one more belief that stops a lot of people. It's the idea that you need special tools or expensive software or a big team or a company with a massive budget in order to design a high-quality database. And I want to remove that belief completely. Because great database design is about thinking clearly and following a process, not about the tools that you use. I've worked in many teams that involved creating or enhancing a database. Sometimes we did this in Microsoft Visio, but other times we didn't have the budget for that. Other times we've used Confluence and a simple diagramming tool. Other times we've used pen and paper, which is primitive but a good way to get started. I've even used some of the more collaborative modern tools like Miro to put together simple diagrams. We still aim to follow a simple process like this, and the result was a clean, flexible database that scaled with the team's product for years. No Visio, no enterprise licenses, no big budget architecture tools, just clarity and a repeatable process. On the other hand, I've worked with large organizations who did have access to these kinds of tools, but because they didn't follow a process, their designs were chaotic. Too many tables, no documentation, unclear relationships, and duplicate data everywhere. The tools didn't save them, but the process would have. So if you're thinking, I don't have the right tools, or my workplace doesn't have a design budget, or I can't convince my team to buy software, you can let go of all of that. Here's all you really need to start designing great databases: a notepad, a whiteboard, a simple diagramming tool, or even just a piece of paper. What matters is the clarity of the design, not the software you use to draw it. You also don't need extra time allocated in your sprint or project plan. Most teams underestimate how much time clean design saves later. A few minutes clarifying an entity now prevents hours of debugging and refactoring later. A simple relationship review or clarification today prevents a major schema rewrite when the app goes live. Designing properly is not extra work. It's the work that makes everything else easier. And the blueprint you've learned in this video makes the process quick, simple, and repeatable, even if you're working alone or in a team that isn't used to formal design. Now, inside my course, Effective Database Design, I go much further into the process and checklists you can use to speed up your process and make your designs even more robust. And even how to create the real database by translating the design into SQL statements. But for now, all you need to believe is this: lack of tools is not a barrier, lack of process is. And now you have the process. At this point, you now understand the full blueprint. You've seen the belief shifts behind it, and you know that you don't need a special title or special software to do this well. The only question now is, do you want to learn how to apply this blueprint the right way, with real examples, guided lessons, and complete checklists that walk you through every step? If so, let me show you what I've created to help you do exactly that. Now that you've seen the full blueprint, you might be thinking, this makes so much sense, but I'd love to watch you do this on a real project, step by step, and follow the exact process myself. And that's exactly why I created Effective Database Design. It's my complete, practical, real-world course that shows you how to go from a blank page to a fully designed database that you can confidently build in any SQL database. If you want a clear, repeatable process that you can use for every future project, this is the course that gives you that structure. Let me show you what's inside. In Module 1, you'll learn how to start every database project the right way. You'll discover how to easily gather the requirements, how to turn vague ideas into clear, usable statements, and how to create the type of diagram we'll be using throughout the course, which is a simple, clean entity relationship diagram. You'll lay the foundation for your entire design. In Module 2, you start actually creating the diagram of your database design. You'll take the requirements from Module 1 and translate them into a real database design. I walk you through the entire process step by step, adding your first table, adding attributes, adding new tables as they appear in your requirements, and relating everything together with the right relationship types. By the end of this module, you'll have a complete, consistent database design based entirely on your requirements. A design is only useful if it actually works in real scenarios. In Module 3, you'll learn how to test your database using realistic data situations. You'll create a set of scenarios that the database needs to handle and follow a structured checklist to analyze your design. This is where you spot weaknesses early and refine your structure before writing any SQL. Now that your design is solid, you'll learn how to turn it into SQL. In Module 4, I walk you through writing the SQL statements to create your tables, define relationships, and insert your sample data. You'll also learn how to run simple queries to validate everything. This means that by the end of the course, you'll have a working database you can use immediately. And that's just the core training. You also get 3 bonuses. The first is my table assessment guide. This is a series of questions you can ask yourself to refine each table in your design. It helps you determine exactly what belongs in a table, what doesn't, and how to update your structure based on the answers. This makes your design cleaner, clearer, and more stable. Bonus number 2 is my common database design solutions. This is one of the most useful resources I've ever created. It includes a collection of the most common database design scenarios like handling names, addresses, soft deletes, categories, similar records, and many more, along with recommended solutions, diagrams, and explanations. This alone will save you hours on every project. The third bonus is that you get a full PDF version of the entire course, every lesson in a PDF format. You can use it offline, print it, or keep it open as a reference while you're designing your next database. If you add it all up, the complete video course, the table assessment guide, the design solutions, and the full PDF reference, the total value comes to $738. But of course, you're not going to pay $738 today. The full price of effective database design is just $97. You get lifetime access, free updates, all modules, all bonuses, and immediate access. If you've ever wanted to feel confident designing databases, if you've ever wanted to avoid the endless confusion, guesswork, and redesign, and if you want a simple blueprint you can use for every project moving forward, then this is the course that will get you there. Just click the link in the description or the pinned comment to enroll. You'll get instant access and you can start designing your first database today. As part of this course, I offer all customers a 30-day money-back guarantee. I'm very confident that this course can help you design an effective database. If you enroll in this course and are not satisfied with it, let me know within 30 days of enrolling and I'll provide a refund for you. There's no need to get on a Zoom call or fill out a survey. Just send me an email and ask for a refund and I'll process it. So now you've seen the full picture. You've seen the 5-step blueprint. You've seen how professionals approach database design. And you've seen why it's not about guesswork or expensive tools or having a DBA title. It's about following a clear, structured process that gives you confidence at every step. And I want to leave you with this. Database design is one of those skills that pays off for the rest of your career. Every project becomes easier. Every requirement becomes clearer. Every query becomes faster to write. And your teammates start relying on you as the person who gets databases. It's a skill that makes you more valuable, whether you're a software developer, a data analyst, a student, or someone who simply wants to understand data better. And that's why I created Effective Database Design, to give you a complete, reusable framework that you can rely on for every database you build from this point forward. If the blueprint made sense to you and if you can see how having the full process and explanation would make your projects faster and easier, then I'd love to help you take the next step. Just click the link in the description or the pinned comment and you can enroll today for just $97. You'll get instant access to all modules, all bonuses, and lifetime updates, so you can revisit the course anytime you start a new project. If you're not ready yet, that's completely fine. Keep learning and keep exploring. But if you are ready and you want a clear, proven process that removes the confusion and guesswork from your database design, then join me inside the course and I'll guide you through every step. Here are some of the common questions I get about this course and my courses. What does lifetime access mean? It means that you pay once and get access to this course for the life of my business, which I plan on being for a long time. There are no annual fees or ongoing charges to pay. You get access after a single payment. If I ever decide to shut down the business, you'll have the ability to download the videos. What vendors does this work for? The database design process and this course will work for any relational database. I mainly focus on 4 databases when teaching SQL: Oracle, SQL Server, MySQL, and PostgreSQL, but you can use these processes for these or any other database. The process to create SQL is demonstrated in MySQL, but you can apply it to any other SQL database. What level of knowledge do I need before joining? You'll need to have a basic understanding of databases, such as what they are and what tables and columns are. To convert the design into SQL, it's helpful to know some of the basic SQL statements such as create table and insert. Once again, if you're ready for this course, check out the link in the description to join. Thanks so much for watching, and I'll see you in the next video.